Okay, so in this video I'm going to have a look at logs or logarithms. I'm going to have a look at what they are, generally what the graph looks like, and the laws of logs, and I'm going to do a couple of examples of questions or problems with logs in them. So first of all, let's just have a look at this here. This is what we've seen before when we did indices. 2 to the power of 3 is equal to 8. 2 times 2 times 2 gives you 8. Now if we want to write this in log format, in a different format, you would write it like this. Log of 8 to the base 2, this 2 here is called the base, that number there is called the base. Log 8 to the base 2 is 3. In other words, if you take 2, raise it to that power there, you'll get this number here. So all we've done is taken index form and written it in log form. They're exactly the same equations, just written a different way. We're using this word log here. Okay, so let's just have a look at the graphs of this is the graph of an exponential function here. Y is equal to 2 to the power of x. We've seen that in previous videos. Okay, so this is the graph of 2 to the power of x. This is the line y is equal to x. It's just a line, a straight line at 45-degree angle. In other words, for each y is equal to each x on each point on this line. So if you go out 1, you'll go up 1. If you go out 2, you'll go up 2. If you go out 3, you'll go up 3. So y is equal to x on this line. The log function, when we graph the log function, it's the mirror image of the exponential function in this line. It's reflected in this line here, y is equal to x. So this is our exponential function. This is what our log function will look like. In our exponential function, the y values never go below 0. In the log function, our x values will never go below 0. Okay, so that's our log graphs and the way we actually write logs. And you'll see on your calculator as well that there's a log button, log. There's also a button called ln. That's exactly the same as log, but we use a base e. Okay, ln, you just use this button here, ln. So you can say it's called a natural log. This is ln, or log to the base e. Okay, so let's have a look at the laws of logs. So the first one is the first law is if we have two numbers multiplied. So let's just have a look. We've got a log of, let's say, x multiplied by y, and we'll say our base here is a. So the log of some number, we raise a to some number to give us x multiplied by y. Well, you can break that down. You can say that that's exactly the same as log x to the base a plus log y to the base a. So that's our first law of logs. Second one then is if we have the log of two things divided, or one thing divided by another. So for example, if we have x divided by y to the base a, so in other words, a to the power of something will give me x divided by y. So that's just log x to the base a minus log y to the base a. So we're just subtracting here. The third one we're going to look at is the log of, let's say, x to the power of q, and again to the base a. This is a very useful law, and it comes up quite a lot in questions. What you can do here is take this power, bring it down here to the front of the log, and what you end up with is q times log x to the base a. And you can do it in reverse as well. If you got some number multiplied by a log, you can take this number here, bring it up here as a power. So you can use it in both directions, obviously. Okay, so that's number 3. Let's have a look at number 4. So number 4 just says that the log of 1 to the base a is 0. In other words, if you take a, raise it to the power of 0, your answer will be 1. And we saw that when we did indices. Number 5, I'll do it over here. I'm just running out of room here. So let's say number 5 here is log, let's say 1 over x. to the base a, that's going to be minus log x to the base a. And that's because we know here that 1 over x is just, that's 1 over x to the power of 1. So that's just x to the power of minus 1. So 1 over x is x to the power of minus 1. So we know we've seen from here that if we have a power, we can take that power and bring it down to the front of the log. So if this is x to the power of minus 1, we can take this power and just bring it down to the front of the log here, so we get minus 1 times log x. So that's where that comes from. So number 6 then is log of a to the power of x to the base a. That's just going to be x. Because if you think about it, if you take this a here, what do you have to raise that a to the power of? What do you have to put up here? What do you have to raise that a to the power of to give you a to the power of x? Well, it has to be x. You have to put an x in here to give you a to the power of x. Okay, so that's number 6. So let's have a look at the next one. Number 7. If you've got a to the power of log a to the power of x, that's just simply x. And the last one, that I won't go into too much detail on that, but let's have a look at the last one. This is very useful, this last one. If you have a base that you don't want to use and you want to turn it into a different base, you can use this one. So this one is log x to the base b. Now, if you want to change this b into, let's say, an a, you don't like this particular base here, you want to change it into a different base, what you do is just simply write down log of x to the base a divided by log b to the base a. So now instead of using base a, or using base b here, you're now using base a. So you've gotten rid of the base b. Okay, so there are laws of logs. What I'm going to do now is just take a couple of examples of questions that you might come across. So let's have a look at the first one here. First question. Let's say we have log 3 to the base 2 plus log x plus 1 to the base 2. We're going to say that's equal to log x plus 11, and we'll say that's also to the base 2. Now the question, this is the question you're given, and you're asked to solve for x. You're asked to find out what x is. So you've got to isolate x here. So down here somewhere you're going to end up with x is equal to some number. So let's have a look at what we can do here. Well, we have log of a number to the base 2 plus log of a number to the base 2. That's just simply the first law of logs. So what we can do is multiply these two logs here. So you can write this as log 3 multiplied by x plus 1 all to the base 2 is equal to log x plus 11 to the base 2. So this is the first law of logs in reverse, if you like. You've got log 3 to the base 2 plus log of x plus 1 to the base 2. So we can just take 3 and multiply it by x plus 1 to the base 2. Now, at this stage what you can do is say that if you have log of this number here to the base 2 is equal to log of this number to the base 2, then these two numbers must be equal. The log of something to the base 2 is equal to the log of something to the base 2, then the two somethings must be equal. So in other words, in this case you've got 3 times x plus 1 must be equal to x plus 11. Because we've got log 2 and log 2 here. So let's just multiply that out on the left hand side. We get 3x plus 3 is equal to x plus 11, and on this side then let's take that x, bring it over here. We've got 2x, let's take the 3, bring it over here. That'll give us 2x is equal to 8. That'll give me x is equal to 4. So we've isolated the x here. We found that x is equal to 4. And if you work that out up here, you'll find that it works. Log of 3 to the base 2. You can do that on your calculators. Here you've got log of 4 plus 1, log of 5 to the base 2. If you add those two together, that's equal to the log of 4 plus 11, the log of 15 to the base 2. Okay, so that's my first example, a fairly straightforward example using one or two laws of logs there. Second one is a little bit more complicated, a little bit more detailed. So let's have a look at that one. Okay, so we have log, whoops, let's get rid of that and move up again. Okay, so in this case we have log of 2x plus 4, 2x plus 4, and this is to the base 27, plus log to the base 81, and we've got 6x plus 12. 6x plus 12. That's equal to 5 over 6. Now, this is going to require a bit of work, but we just simply work through the laws of logs and we should end up down here somewhere with x is equal to some number. So we see here we've got a base 27, we've got a base 81. So we've got two different bases, so it's very useful to change those to the same base. Now, we can see that 27 and 81 are related in that they're, 3 cubed will give me 27 and 3 to the power of 4 will give me 81. So what I think I'll do is reduce both of these to the base 3. So, and I think that will work out for me. So let's just see what happens. I'm going to change this first of all using the laws of indices, using the last law, law 8 I think it was. I'm going to change this to the base 3. So I'm going to write log 2x plus 4 to the base 3 over log 27 to the base 3. So it's log of this to the base 3 divided by log this to the base 3. Now instead of a log of base 27 here, I've now got a log to the base 3. I'm going to do the same here. So this is going to be log 6x plus 12. Again, that's to the base 3. And that will give me log on the bottom here to the base 3 of 81, this number here, my original base. And that's equal to 5 over 6. Now, what I end up on the bottom here is 3 to the power of something will give me 27. You can do this on your calculator either. 3, this number here, to the power of something will give me 27. Well, 3 to the power of 3 will give me 27. So this number on the bottom just turns into a 3. So here I've got log 2x plus 4 to the base 3. And on the bottom, I've just got the number 3. Over here on the top, I've got log 6x plus 12, again to the base 3. And on the bottom here, log of 81 to the base 3. If you do that on your calculator, you'll get 4. In other words, 3 to the power of what will give me 81? Well, 3 to the power of 4 will give me 81. And on the right-hand side, I've got 5 over 6. Whoops, 5 over 6 here. Okay, so now look, I've got three fractions here. I've got a 3, a 4, and a 6 on the bottom part of the fraction. The denominators are 3, 4, and 6. So what I'm going to do here is I'm going to multiply everything by 12. So I'm going to take this fraction here and I'm going to multiply by 12 over 1. This fraction here I'm going to multiply by 12 over 1. And this fraction here I'm going to multiply by 12 over 1. So what happens if I do that? Well, this 3 will divide into this 12 4 times. So I end up with 4 times log 2x plus 4, and again to the base 3. Over here, this 4 will divide into this 12 3 times. So I end up with 3 times log 6x plus 12. That's to the base 3. Over here, this 6 will divide into this 12 twice, so 2 5s then give me 10. So now I've gotten rid of the fractions, and I just have the one base 3. So we're getting there anyway. So let's move this up here a little bit again and continue on. Now I'm going to use the which law was it? I think it was the third law, and I'm going to take this 4 here and I'm going to move it up here. I'm going to take this 3 here in front of the log. I'm going to move it up here. So what I end up with is log to the base 3 of 2x plus 4 to the power of 4. plus log 6x plus 12, and this is going to be to the power of 3. And to the base 3 as well, and that's going to be equal to 10. Now, one last thing I'm going to do before I continue. You can see here you got a base 3 and a base 3, so I can multiply these two here. But one last thing before I do that, I'm just going to factorize this thing here in the brackets, because I'd like to have a 2x plus 4 and a 2x plus 4 here. So what I'm going to do is I'm going to take log to the base 3 of 2x plus 4, and that's the power of 4, plus log, now this is the base 3. What I'm going to do here is I'm going to factorize this. I'm going to take out 3, so I'm going to end up with 2x plus 4, and all of that's to the power of 3, and that's equal to 10. So all I've done is factorize this 6x plus 12 to give me 3 times 2x plus 4. Because I'd like to have a 2x plus 4 and a 2x plus 4 here. Now, I'm just going to use the laws of indices here. This is all of this. This 3 is multiplied by the 2x plus 4, all to the power of 3. In other words, if you have xy, and it's to the power of 3, for example, that gives you x cubed, y cubed. So that's what I'm going to do here. I'm going to raise this 3 to the power of 3 and this 2x plus 4 to the power of 3. So let's see what we get here. So I've got log to the base 3, 2x plus 4 to the power of 4, plus log to the base 3 of 3 to the power of 3 and 2x plus 4 to the power of 3. And that's equal to 10. Okay, so now what I'm going to do is use the first law of indices in reverse. I've got log of something to the base 3 plus log of something to the base 3. So these two somethings I can multiply. So I end up with log to the base 3 of 2x plus 4 multiplied by 3 to the power of 3 times 2x plus 4 to the power of 3 equal to 10. So I have log of this plus log of all of this, both to the base 3. So this and all of this I can just multiply. That's what I've done here. Okay, so let's continue on then. Now I'm going to use the law of indices now, which I did in a previous video. I've got 2x to the power of 4. By the way, that's to the power of 4. I forgot to put that 4 in here. So this is 2x plus 4 to the power of 4 multiplied by 2x plus 4 to the power of 3. Now remember in the previous video, if you had x to the power of y times z to the power of, let's say, m, or n there, looks more like an n. You can add the index. No, sorry, I'll start that again. Let me just start that one again. Okay, so if you have, let's say, x to the power of m, x to the power of n, that's x to the power of m plus n. When you have the same number here, this x, you have x to the power of m, x to the power of n, you add the indices when you're multiplying these two here. So that's what I'm going to do here. I've got 2x plus 4 to the power of 4, 2x plus 4 to the power of 3, so I'm going to add the powers. So I end up with log to the base 3, 2x plus 4, 4 plus 3 gives me 7. And then I've got 3 to the power of 3 here equals 10. So all I've done is added the 3 and the 4 here, because I've got the same base here, 2x plus 4, 2x plus 4. Okay, so now what I'm going to do is I'm going to split it up again. I'm going to use the first law of indices again, or the first law of logs, I should say, again. I've got log of something times something equals 10. So what I'm going to do is say log of 2x plus 4 to the power of 7, the base 3, plus log 3 to the base 3 equals 10. That's 3 to the power of 3, of course. So I have log of this multiplied by this. so I can add them. Okay, so I got log of this to the power of 7 plus log of this here, 3 to the power of 3 to the base 3 equals 10. So all I've done here is use the first law of logs, where you've got two things multiplied, the log of two things multiplied, you can add. So the log of the first one plus the log of the second one. Okay, so let's see what we end up with. This gives us log 2x plus 4 to the power of 7 to the base 3 plus now log of 3 cubed to the base 3. What do I have to raise 3 to the power of to give me 3 to the power of 3? Well, it's just simply 3. Okay, so 3. What do I have to raise 3 to the power of to give me 3 to the power of 3? Well, I'd have to raise it to the power of 3, so my answer here is 3. Bring this 3 over here, so I end up with log 2x plus 4 to the power of 7 is equal to 10 minus 3, which is 7. Okay, so this is to the base 3 as well. Okay, so we're getting there. Now, what I'm going to do now is convert this into index form, from log form to index form. So in other words, 3 to the power of 7 should give me 2x plus 4 to the power of 7. 3 to the power of this number here, so this number here to the power of this number here will give me all of this here. 3 to the power of 7 gives me 2x plus 4 to the power of 7. Okay, so oops, we'll go back to white again. So okay, so we have 3 to the power of 7 is equal to 2x plus 4 to the power of 7. So 3 to the power of 7 equals 2x plus 4 to the power of 7. That will mean that 2x plus 4 must be equal to 3. I've got something to the power of 7 equals something to the power of 7. That means the two somethings must be the same. In other words, that 2x plus 4 there must be equal to 3. Okay? 3 to the power of 7 equals 2x plus 4 to the power of 7. So this here must be equal to 3. So then just simply bring the 4 over here, and you get minus 1, 3 minus 4. And that will finally give me x is equal to minus 1 over 2. So okay, that was a long process just to get to this this value of x here. X is equal to minus a half, but we used a number of laws of logs there, and even one or two laws of indices. Okay, so that's it for logs.